we look at question 4. Okay, show that the vector field f x y z equal to y exponent negative xi plus z exponent y minus exponent negative xj plus exponent yk is conservative, and find its potential function phi xyz. So this type is friendly question because they already mentioned conservative. Then you know you should use the concept of conservative vector field and then use a potential function phi to evaluate your line integral. Okay. So this one is the conservative vector field. Question 4. Hold on. Okay, 4H. Question 4. Okay, the vector f component I is y exponent negative x. Component j is z exponent y minus exponent negative x. Component k is exponent y. Okay, they ask to show that f is conservative, then you need to find del cross f, which is called as curl of vector f. Okay, del is a differential operator. If f is 3 dimension, then the del will be 3 dimension 2, which is del del xi, and then you have the del del yj. Component k is a del del zk. This is del. So cross with vector f. So y component I is y exponent negative x. Component j is z exponent y minus exponent negative x. Component k is exponent y. Okay, the question show f is conservative. So the question is also is a positive sentence. So mean the answer must be conservative and the curl of f must be 0. Unless the question justify if f is conservative, then you are unsure. If show is conservative, so mean the answer is positive. Okay, it is confirmed that curl of f must be 0. Okay, but you need to show the step there. Okay, for component I, what you need to do, del cross f, the result is vector, so you should have component I, j, k. For component I, you cross it, so you left j cross k, you get I. Okay, j cross k, you have here main diagonal deduct with the other diagonal. Okay, so component I, you have del del y exponent y. Okay, if you cannot do it slowly, del del y exponent y. Okay, minus your del del z exponent y minus exponent negative x. Okay, this is component I. Okay, and then let me put it down. Let's say should enough. Okay, component I, del del y exponent y, you should get exponent y. Del del z exponent y, when you del del z, x and y are constant. So you del del z constant time of z, the answer is constant times z. So answer is exponent y. Del del z constant 0. So exponent y minus exponent y. So component I, you see, you already obtained 0. Okay, now we do component j. Okay, component j, you close it. Okay, and I cross k is negative j. So that's why you got negative. Let me make sure here. And then you use the same direction, main diagonal, which is del del x exponent y minus del del z y exponent negative x. This is component j. Okay, we look at When you delta x, y and z are constant. So you delta x a constant, okay, you have 0 and then minus, yeah, I put it properly. Negative and then 0. Delta z, okay, y and x are constant, so 0. So component j already obtained 0. Okay, now we do for component k. This is delta x. Okay, for component k, okay, close it, and then I cross j is positive k. So delta x, okay, so is you delta x z exponent y minus exponent negative x, okay, minus, okay, the other product, okay, minus delta x y exponent negative x, okay, so component I j k. When delta x, y and z are constant, so you delta x the first term yz, delta x constant 0, so you delta x negative exponent negative x, so differentiation, okay, the negative bring in front, so negative negative positive, so component k first term you get exponent negative x, so minus, okay, when you delta x, okay, y is constant, so you have, and then you factor out y, so you should have this is y, and then you delta x exponent negative x. Oh, the question is wrong. I cannot get 0. Okay, or any mistake. Okay, because delta x exponent negative x, we should have negative xy. We then I want. Okay, why not 0? Okay, hold on. Checking any question 4. Question 4. Y exponent negative x, z exponent y minus exponent negative x, exponent y, component k, delta x, z exponent y minus exponent negative x. Delta x, this one is 0. So this one I get exponent negative x. Okay, and then delta x, oh, sorry, this delta y. No wonder, because just now erased right wrongly. Okay, delta y. Delta y, y exponent negative x. When delta y, x is constant, that's why you get, correct. This one just now when I, okay, erase that that vertical line, I, okay, wrote wrongly. This is delta y. So delta x, z exponent y minus exponent negative x. Okay, we get the answer first term. Delta x, z exponent y, this is 0. Delta x, negative exponent negative x, we have positive exponent negative x. So minus delta y, y exponent negative x. Okay, when delta y, x is constant, that's why you get minus exponent negative x. So component I, j, k, all we obtain 0. Okay, therefore F is conservative vector field. So that's why if the question show that vector F is conservative and the answer is true, unless the question justify if vector F is conservative, then you are unsure whether it is conservative or not. Okay, so this one confirm that F is conservative, then curl of F will be equal to 0 vector. Okay, after that, you need to find its potential function phi xyz. Okay, and then use that potential function phi xyz to evaluate the line integral. Okay, then we find the potential function phi. Okay, phi. Yeah. Go to where already? Okay, here. Okay, phi. Okay, use this one. Phi x, y, z. To get the phi is very easy. Okay. Okay, when f is conservative, okay, when f is conservative, then f equal to del phi. Okay, write down the f. Okay, f is component I is y exponent negative x. Component j is z exponent y minus exponent negative x. Component k is exponent y. Okay, del phi. Okay, del is a differential operator. So when f is 3-dimension, the del also 3-dimension. So del del xi plus del del yj plus del del zk. Phi is a scalar. Phi is a scalar function. So vector times scalar, you get del phi is actually, because this is scalar, the result is vector. Vector times scalar is vector. So you get del phi del x I, del phi del yj, del phi del zk. So mean is when f is conservative, exists one potential function such that f equal to del phi. Then we are going to use a phi to find the line integral. Okay, and then you compare component by component. Compare component I, then the del phi del x equal to y exponent negative x. To get phi, you integrate, okay, the respect to dx at both hand side. That's why the phi x, y, z is equal to, you integrate the first component of your f respect to x. And then this one integrate respect to y, the third component integrate respect to z. So integrate y exponent negative x dx. And this is, okay, when you integrate respect to x, this is partial integration where y and z are constant. Okay, y constant, so you can factor out y. So integrate exponent negative x dx. Okay, you have y exponent negative x divide by, okay, -1. So you get negative here. So the constant is actually function of y and z. Because this is partial integration. When integrate respect to x, y and z are constant. So this is the first equation that you can obtain from component I. Okay, from component j, you have del phi del y equal to z exponent y minus exponent negative x. Hence, to get the phi, you can, okay, integrate respect to y at both hand side. That's why phi x, y, z equal to, you integrate z exponent y minus exponent negative x respect to y. So when you integrate respect to y, x and z are constant. So z here, this is constant. Okay, x is constant. Okay, so integrate z exponent y where z is constant. So you get z exponent y. Okay, integrate respect to y, the whole term exponent negative x is constant. So you get constant, which is constant multiplied by y. Okay, and then, okay, so integrate respect to y, okay, your constant including x and z. So this is the second equation. And then from component k, your del phi del z, okay, del phi del z, you compare component k, del phi del z equal to exponent y. Exponent y. Then to get the phi, you can integrate dz to eliminate this one. So when integrate del del z dz, we get back phi x yz is actually integrate exponent y dz. When you integrate respect to z, x and y are constant. That's why this one you get a constant times z. Okay. So the constant is actually in terms of x and y. Okay. And then to get the phi, you start from equation 1. To get the phi x, y, z. Okay. Take out from equation 1. Equation 1, you have what? Negative y exponent negative x. Okay. You got negative, y exponent negative x. Okay, from equation 1. Okay, plus function of y and z. If we start from equation 1, function of y and z, is actually referred to this one. So this same term don't take. So start from equation 1, function of y and z actually refer z exponent y. Okay, so you add up plus z exponent y. Okay, this one already have, we don't take it. Function of x and z, here. This is y and z. But this term we, so this, so that's why gxz is actually a constant c. So you can add up with c here. Okay, or you just, equation 1, you take this term, add up new term. This one already have, don't take it. The third one, this one already take it. Z exponent y, same. I mean the same term is here. This one. Same term take one time. This term and this term same take one time. So 1, 2. So plus the constant k. K. Constant k. Constant k. So this is a phi. See a phi. Question 4. Phi. Now here. Exponent y z. Exponent y times z. And then minus exponent negative xy. So minus exponent negative xy. So phi is correct. After that, so when f is conservative, exists one potential function phi, such that f equal to del phi, and then you can use the potential function phi to evaluate the line integral. Then the line integral of question 4, which is cy exponent negative x dx plus z exponent y minus exponent negative x, this is dy plus exponent y dz. Here. Evaluate the line integral here. When f is conservative, the line integral, normally we have the f dot dr. Conservative vector field, then when f is conservative vector field, the line integral of vector field f dot dr, you can use a potential function, but here we have actually shows that f dot dr, if you do your f dot dr, you see here, when you evaluate, your line integral f dot dr is equivalent to your integral of m dx plus n dy plus n dz. Let's say when you put the component f is a m, component I of your vector f is m, component j is n, component k is p. Dr, let's say r t is, this is xti plus y tj plus ztk. Okay, dr you will have okay x mean dx, okay, dx dt, this is dy dt, this is dz dt. Okay, so this is dr dt, so dt bring to the other side, so you got this is actually dx dt dy dt, component k is dz dt, so multiply with dt, so you cancel out, it will become the m dx, d mean the dt here cancel out, you got m dx plus n dy plus p dz. So that's why for the line integral of vector field f dot dr, if f is conservative, then we can use either the simplest path to evaluate the line integral, or you can use potential function phi. Okay, only this question, the f is not, they not give in f dot dr, they give is m dx. So m is component I here. Okay, this is a m dx, this is a n dy, this is a m and p dz. So mean the f dot dr is equivalent to the line integral of differential form, which is a integral m dx plus n dy plus p dz. Okay, hence we will use the potential function phi, easy because the three if you want to do on the along the path joining 0 0 to 3 3 3, then you need to get the parametric equation. Since we obtained the potential function phi already, we must well use the potential function phi to evaluate the line integral here. So therefore this one we will use equal to the potential function phi, which is the negative y exponent negative x plus z exponent y plus k. Then if you evaluate the line integral of a vector field or the differential form, they are equivalent using potential function phi, then you must have the starting point will be the lower limit. Starting point is 0 0 0 up, ending point is 3 3 3. Then you got 0 0 0 to 3 3 3. Okay, and then you can quickly key in this function into your scientific calculator, and then evaluate it faster. You can key in because your calculator you don't have z, let's say you use m, so negative y and then exponent, that's exponent negative x. So y exponent negative x plus z, I use a variable y, m exponent and then exponent, oh not long, shift here, missing, and then again negative y exponent, shift this one, negative x, variable z, I use m, and then exponent y, shift long y, alpha y. So I key in into the calculator, negative y exponent negative x, plus plus z, I use variable m exponent y, k will be cancel each other. When you put up upper limit with positive k, deduct with lower limit k minus k cancel out. And then I calculate, I will calculate upper limit first, which is y is 3, x is 3, z is variable m, which is 3, so you get 60.1072. This one, then calculate again. Now y is 0, x is 0, z is 0. I get 0. So the answer is 60.1072. Question 4, okay. 3 exponent 3, okay. Okay, this is they use manual, okay. Let's check. 3 shift exponent 3 minus exponent shift exponent negative 3. No, sorry, delete. Same. So okay, we obtain the answer. This answer is you solve manually. Okay, just now, okay, the answer I use a calculator. 60.1072.